Good day everyone and welcome to General Chemistry 1 Lesson 6, which is calculating empirical formula and molecular formula. So let's first talk about the empirical formula. So this is a chemical formula showing the simplest whole number ratio of elements in a compound, rather than the total number of atoms in the molecule. So how do we get the empirical formula of a specific compound? For example, we have this problem. A compound of iron and oxygen is analyzed and found to contain 69.94% of iron and 30.06% of oxygen. We have to find the empirical formula of these compounds. So to get these, we have to follow 4 steps, starting with step 1. We have to start with the number of grams of each element given in the problem. If the percentages are given, assume that the total mass is 100 grams, so that the mass of each element is equal to the percent given. On this problem, we have 69.94% of iron, so that is equal to 69.94 grams. For oxygen, we have 30.06%, so that is equal to 30.06 grams. For step 2, we have to convert the mass of each element to moles using the molar mass from the periodic table. So looking at your periodic table, the atomic weight of iron is 55.85 grams. This means that in every 1 mole of iron, there are 55.85 grams. In our given, we have 69.94 grams of iron. So 69.94 grams of iron multiplied to 1 mole divided by 55.85 grams will give you an answer of 1.252 moles of iron. Now for oxygen, the atomic mass of oxygen is 16 grams. This means that in every 1 mole of oxygen, there are 16 grams of oxygen. So the given is 30.06 grams multiplied to 1 mole divided by 16 grams will give you an answer of 1.879 moles of oxygen. For step 3, we have to divide each mole by the smallest number of moles calculated. Going back, the smallest number of mole calculated is 1.252. So that's what we're going to use. So 1.252 divided by 1.252 will give you an answer of 1. For oxygen, we have 1.879 divided by 1.252 will give you an answer of 1.5. For step 4, we have to round the nearest whole number. This is the mole ratio of the elements and is represented by subscripts in the empirical formula. But if the number is too far to round, like for example is 0.9 or 0.1, then multiply each solution by the same factor to get the lowest whole number multiple. For example, if one solution is 1.5, then multiply its solution in the problem by 2 to get the whole number 3. Another one, if the solution is 1.25, then multiply each solution in the problem by 4 to get the whole number 5. So going back, the one of the solution is 1.5, so we have to convert this into whole number. Since the mole of oxygen is not a whole number, both moles can be multiplied by 2 while rounding to a whole number. So 1 times 2 will give you an answer of 2. 1.5 times 2 will give you an answer of 3. This will serve as the subscripts of the elements. So the empirical formula of the compound will be Fe2O3 or iron 3 oxide. Okay, so we have here another problem. A compound was analyzed and found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. Now, what is the empirical formula of the compound? Like what we did before, we have to start with the number of grams of each element. Since the grams are already given, we have to copy it. So we have 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. Now for step 2, we have to convert the mass of each element to moles using the molar mass from the periodic table. So first we have to write the given grams, which is 13.50 grams of calcium. Now in every 1 mole of calcium there are 40.08 grams. So 13.50 times 1 divided by 40.08 will give you an answer of 0.337 moles of calcium. Next, for oxygen, our given is 10.80 grams. So in every 1 mole of oxygen, there are 16 grams. So 10.80 grams times 1 divided by 16 will give you an answer of 0.675 moles. Now for hydrogen, our given is 0.675 grams. Then in every 1 mole, there are 1.01 grams of hydrogen. So 6.675 grams times 1 divided by 1.01 will give you an answer of 0.668 moles of hydrogen. Now for step 3, we have to divide each mole value by the smallest number of moles calculated. Among the three, the smallest number of mole calculated is 0.337. So this one is the unit that we're going to use. So 0.337 divided by 0.337 moles will give you an answer of 1. For oxygen, we have 0.675 moles divided by 0.337. We'll get the answer of 2. For hydrogen, we have 0.668 moles divided by 0.337. And we'll get an answer of 1.98. Okay. For step 4, we have to round to the nearest whole number. Since one of our solution is 1.98, we have to round this to the nearest whole number, which is 2. 1 and 2 are already whole numbers, so at is. So the empirical formula of the compound will be CaO2 from here and H2. Or we can simply write it as Ca, open and close parenthesis, OH2. This means that both oxygen and hydrogen have a subscript of 2. So this is the empirical formula for calcium hydroxide. Now let's talk about molecular formula. So unlike empirical formula, molecular formula gives the kind of and number of atoms of each element present in the molecular compound. In many cases, the molecular formula is the same as the empirical formula. Now, how do we get the molecular formula of a specific compound? First, we have to calculate the empirical formula mass. Second, we have to divide the gram of molecular mass by the empirical formula mass. Then lastly, we have to multiply each of the subscripts within the empirical formula calculated in step 2. So let's put this into practice. For example, we have this problem. The empirical formula of a compound of boron and hydrogen is BH3. Its molar mass is 27.7 grams. We have to determine the molecular formula of the compound. So for step 1, we have to calculate the empirical formula mass. So to get this, we have to get the atomic weight of each element. So the atomic weight of boron is 10.81. The atomic weight of hydrogen is 1.01. Now, saan galing tong 1 and 3? This will serve as the number of atoms of each element. Boron has 1, hydrogen has 3. So 1 times 10.81, we have 10.81 grams per mole. 3 times 1.01 equals to 3.03 grams per mole. We have to add this through and you'll get an answer of 13.84 grams per mole. So this is the empirical formula mass of these compounds. Step 2. We have to divide the gram of the molecular mass by the empirical formula mass. So our molar mass is 27.70 grams per mole. So here is it. Now, our computed empirical formula mass a while ago is 13.84 grams. So, 27.70 divided by 13.84, you'll get an answer of 2. Now, for step 3, multiply each of the subscript within the empirical formula by the number calculated. So, the number calculated is 2. So, we have to multiply each of the subscripts. So, subscript for B is 1 times 2, you have 2. Subscript for hydrogen is 3. So, 3 times 2, you'll get 6. So, the molecular formula will be B2H6. Now, let's solve another problem. A molecule with a molecular weight of 180.18 grams per mole is analyzed and found to contain 40% of carbon, 6.72% of hydrogen, and 53.28% of oxygen. What is the empirical and molecular formula of these molecules? So since we don't have the empirical formula, we have to solve it first. On the given, we have 40.00% of carbon, so that is equivalent to 40 grams. For hydrogen, we have 6.72%, so that is equivalent to 6.72 grams. For oxygen, we have 53.28%, so that is equivalent to 53.28 grams. Next, we have to get the molar mass of carbon, hydrogen, and oxygen. So, the given is 40%, so we have 40 grams. In every 1 mole of carbon, we have 12.01 grams. So by doing this, 40 times 1 divided by 12.01, you'll get an answer of 3.331 moles. Next, for hydrogen, we have the sample is 6.72 grams times. In every 1 mole of hydrogen, there are 1.01 grams of it. So 6.72 times 1 divided by 1.01, you'll get an answer of 6.653 moles of hydrogen. Now for oxygen, our sample has 53.28 grams. And then in every 1 mole of oxygen, there are 16 grams. So 53.28 times 1 divided by 16 grams will give you an answer of 3.330 moles. Among these 3, we have to compute or to get the smallest value. So the smallest value is 3.330. So we have to use this as the divisor of each solution. So 3.331 divided by 3.330, you get an answer of 1. 6.653 divided by 3.330, we have 2. 3.330 divided by 3.330, we have 1. So this will serve as the subscript of our empirical formula. So we have C, since 1, we don't need to write it anymore. So hydrogen, 2. So 2. Oxygen, we don't have to write 1 anymore. So the empirical formula of this compound is CH2O. Now, since we already get the empirical formula, let's solve for the molecular formula of this molecule. So to get the empirical formula, we have to get first the empirical formula mass for CH2O. there are 1 atom for carbon, 2 atoms for hydrogen, and 1 atom for oxygen. The atomic mass of carbon is 12.01, atomic mass of hydrogen is 1.01, and the atomic mass of oxygen is 16. So multiply 1 times 12.01, you get 12.01 grams. 2 times 2.01, you get 2.02 grams. 1.16, 1 times 16, you get 16 grams. So by adding this 3, you'll get an answer of 30.03 grams per mole. Okay, now we already got the empirical formula mass, which is 30.03 grams. Now we have to divide it with the molar mass. The molar mass given is 180.18 gram per mole. So 180.18 gram per mole divided by 30.03 grams will get an answer of 6. And this 6 will be multiplied with the subscript of each element. So C, imaginary 1, so 1 times 6, you have 6. 2 times 6, you have 12. Oxygen, imaginary na 1, so 1 times 6, you have 6. So the molecular formula will be C6H12O6. And this is the molecule of glucose.